Okay, now I think we're good. Okay, so we'll continue on with 5.3. So today and tomorrow, I'll do as much of 5.2 and 5.3 as possible. Quiz tomorrow. Friday's a holiday. Okay, so the quiz, which is normally on a Friday, will be on Thursday, due at 11:59 p.m. tomorrow, Thursday, the 11th. I'll give that to you tomorrow. Okay, so I'll try to get as much to you of 5.3 as possible. Okay. And 5.3. I think I gave you the problems already, but just in case. Here we are again. And that. And that. One problem on the next page. 65. And that. Okay. So some of my own background first, before we get too deep. So 5.3 is on logs or logarithms. Okay, so if I take the exponential function, let's say e to the x, if I reflect across the line y equals x, then I get x equals e to the y. If you turn around the x and the y, that's what you get. We create a new function called the logarithm function, y equals ln x. Okay, they're both one-to-one functions, which means they both have inverses. Notice they both pass the horizontal and vertical line test. Okay, so e to the x and ln x are inverse functions of each other. Okay, ln stands for natural log or log natural. Okay, so e to the x, again, e is like 2.7. You don't have to memorize that. Or if you want to put it down, you may. It's just like, do you need to memorize pi? Well, pi maybe you already know is 3.14. E is about 2.71. Okay. The domain is all real numbers and the range is 0 to infinity. Therefore, the inverse, they swap. So the domain for the natural log function or any log function is 0 to infinity and the range is all real numbers. Okay, so given y equals an exponential function a to the x, it's 1-to-1. Therefore, it has an inverse. Remember, for inverse, you can switch around x and y. X equals a to the y. How do you solve for y? What we do is we invent a new function called the logarithm function. So y equals log base a of x. This means the same thing as this. If you do my unscrambling root, start with the base a, go across the exponent, go across the equal sign for the exponent, a to the y, and you come back in for the result, a to the y equals x. Okay, now ln x means log base e of x. They mean the same thing. So y equals log base e of x means the same thing as e to the y equals x. Okay. So some examples of logs. So y equals log base b of x. Write it without the log. I mean, most of us aren't that comfortable with logs. So how do you get rid of the log? Start with the base b, exponent, you go across the equal sign, b raised to the y power, come back in for the result, x. Okay, so before doing some homework problems, I thought I'd do some examples so you can kind of see how it works. Log base 2 of 8 equals 3. Okay. Write it without log. So you start with the base 2, you go across the equal sign. Now you might go across the equal sign either on the left or on the right. Just go on the other side of the equal sign, 2 cubed, come back in for the result, 2 cubed equals 8. Okay, log base 10 of 10,000 equals 4. How do you write it without the log? So you take the base 10, across the equal sign for the 4, come back in for the result, 10,000. So 10 to the 4th power is equal to 10,000. Log base 5 of radical 5 is a half, means 5 raised to the half power is equal to square root of 5, like so. Okay, and they just give me letters, like log base a of b equals c. The base is a. You always go on the other side of the equal sign for the exponent. So a raised to the c, come back in for the b. Okay, now how do I go the other way? Suppose I start off with an exponential. How do I write it as a log? Okay, So how do I write as a log? Well, maybe the first thing you should do is write log, right? So write it as a log, put log. Okay, I would start with the base. Which of these three is the base? 3. So 3 goes there. And now the only thing you have to worry about is the 4 and the 81. Remember the 4, the exponent is all by itself. So the 4 is on the other side of the equal sign, and then the 81 comes back in. So log base 3 of 81 equals 4. Okay, so one more time. Of these 3 right here, 1, 2, 3, how do I write as a log? Write log, start with the base. The base is 3. That kind of gets sunken down next to the g here. Okay. Then I just have to worry about the 4 and the 81. The exponent is always by itself on the other side of the equal sign, then come back in for the 81. And by the way, you can double check it, right? 3 to the 4th is 81. Okay, how do I write this as a log? 10 to the negative 2 equals 0.01. Okay, so start off. This arrow means is equivalent to in logic, the double arrow. So write log. Okay, what's the base? 10. Okay, exponent all by itself, negative 2 by itself, 0.01. Okay. And there's another understanding. If the base is 10, you don't have to write it. So log 0.01 equals negative 2. Okay, so the understanding for a log, you're supposed to have an exponent down here anytime you have log. If you don't see it, it's understood to be 10. Okay, that means, for instance, on your calculator, when you just see log, it's base 10. By the way, you can't really forget it because there's a 10 to the x right above it. So if you say, if I see log, oh, what's the base? Look above, 10. Likewise for ln, you can't really forget what the base is. Just peek up here and it says E. Right? And by the way, side note, you can do this on your calculator. Log of 0.01 should be negative 2. So just try 0.01 on this calculator and then hit log. And there it is, negative 2. Okay. All right, and how do I write this as a log? X to the y equals E. So write log, log. Which of these 3 is considered the base? X. Okay. Then the rule is exponent is all by itself. So the y goes way over here and come back in for the z. Okay. And you're welcome to put all these examples on your formula sheet if you wish. Okay, then more about inverses. A to the x and log base a of x are inverse functions. They have to be the same base. So if this is a 2, and this is a 2, this is a 3, this is a 3, this is a 10, this is a 10, this is pi, this is pi. They are inverse functions of each other. Okay. For a bigger than 1, this is what a to the x looks like. This is what log base a of x looks like. And there's the line y equals x, which is supposed to be reflection, right? So inverse functions are reflection across the line y equals x, like that. Okay. So among other things, that means you can only take logs of positive quantities. Okay. So for instance, a log base 10 of 0 does not exist. DNE is an abbreviation for does not exist. So if I try to take a log of 0, for instance, if I try 0 and hit log, you should get an error message. Oops. Yeah, it comes back with a little error there. Okay. And likewise, if I try to hit the log, say ln of -1, that also does not exist. So if I hit -1 and try to hit the natural log, ln right over here, I again get an error message. Okay. So you can only take the log of positive quantities. So if I try to take the ln or log of 8, for instance, that exists. Okay, so 8 ln is 2 point whatever. Okay, and if I do log also, log of 8 is 0.903, whatever. Okay, certainly don't memorize it. I don't memorize these, that's crazy. But there we go. Okay, so you would only take the logarithm of positive quantities. Okay. So now for some problems. Number 1. Place here. Log base 4 of 4 cubed. So I'm starting to do some of the problems in 5.3. Okay. All right. Now the text doesn't say it, but I'll just call it X. Then I will unscramble it. I like to say unscramble it. I didn't even spell unscramble, right? Should be an R there, but anyway, unscramble it. That's not official mathematics terminology, but you know what I mean. Write it without the log. So I go 4 raised to the x power is equal to 4 cubed. Then if you look at this, it should be obvious. X should be 3, right? So x is 3. It's not even really math. Just cover this up. 4 something 4 3. So, I wonder what I should put up here to make them equal. 3, right? That's already the same as that. There's a 3 up here. I guess I bet better not be 2, better not be 4. It should be 3, right? Get them to match. Okay, number 5 says log base 4 of 2. Call it x. This x wasn't in the original problem. Okay, number 5, log base 4 of 2. There's no x there, just call it x. I mean, that's a typical thing you do in math, right? If something you don't know, call it x. Unscramble it. 4 raised to the x power is equal to 2. Now, the next thing you want to do is try to get these to be the same base. These two to be the same base. 4, I can write as 2 squared. This is still 4, right? So 2 squared to the x equals 2, which is the same as 2 to the first. Okay, now I have a property of exponents that says if I have a power of a power, I can multiply the powers. So 2 to the 2x equals 2 to the 1. Okay. So I got it to be like the previous problem. Okay, 2 to some exponent equals 2 to the 1. So what should be behind my thumb? It better be equal to 1. So 2x equals 1, x equals a half. Okay, so that's sort of the way that this works. Okay, 7, log base 10 of 0.001. Okay, again, call it x. This kind of problem, by the way, you're supposed to do without a calculator, but we can verify with a calculator. Okay, our calculators can do log base 10 and log base e. They can know more. So log base 10 of 0.001 is x. Okay, unscramble it. 10 to the x equals 0.001. Okay, so the next job is I need to force this side to have base 10 also. Well, 0.001 is 1 over 1,000, right? That's the tenths place, hundreds, thousands, it's 1,000th, which I can write as 1,000 to the negative 1. Property of exponents, right? Now, how do I write 1,000 so it's base 10? 1,000 is 10 raised to the 3rd power. 10 cubed to the negative 1. And then I have a property that says if I have a power of a power, I can multiply these powers. So 10 to the negative 3rd. 10 to the x equals 10 to the negative 3. Therefore, x equals negative 3. So the answer is negative 3. Now, that should be done without a calculator, but this one you can check on a calculator, the log of 0.001. Since your log button is base 10, you can do this one. So the log of 0.001 should come out to be negative 3. So let me try 0.001, and then I'll hit the log. And there it is, negative 3. It works. Okay. All right, now a little review of a function and its inverse. If you ever compose a function with its inverse, f, circle f inverse of x, you get back x. And likewise, f inverse of f of x is x. Okay, wherever the function is defined. Okay? It's a function with its inverse. So that means anytime you see something that looks like this, log base a of a to the x, there's a log followed by an exponential. And it's as if you can just cancel all of this out and just put down the x. Okay? So a log exponential. Similarly, exponential followed by log. A raised to the log base a of x. Function inverse, just cross this all out and you get x. Okay. In particular, e to the x and ln x are inverse functions of each other. So anytime you see an e with an ln or an ln with an e back to back, they cancel out. So that means ln of e to the x is x. ln and e, just cancel them out. Or it could look like this, e to the ln x. Just cancel the e and the ln is x. They knock each other out. Okay. You're welcome to put these on your cheat sheet. Okay. Similarly, for logs like this, okay, remember if it just says log and they don't put anything there, it means base 10. So on your calculator, it just says log, pretend there's a little 10 here. And like I said, you can't really forget it because if you just peek above, say, oh, there's 10, it's base 10. And for ln, you can't really forget what the base is because right above most calculators, above the ln, it says e. You say, oh, what's the base? It's e. What's e? It's like 2.718, something like that. It's an irrational number, just like pi. Pi is 3.141, blah, 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 right? And e is like 2.71828, something like that. Okay, so log base 10 of 10 to the x, this whole thing will cancel out to x. Or they can write it like this, 10 raised to the log of x. Again, this is understood to be log base 10. 10 raised to the log of x is x. They have to be the same base. So let's pretend this is a 10 and this is a 7, then no, don't cancel them out. Okay, or if this is an e and this is base 2, then don't do that. Okay. Moving right along. I'm trying to say here. So 5.3 continued. The exponential function and the log function to the same base are inverses of each other. Okay. So if f of x is a to the x, f inverse is log base a of x. Okay, you're welcome to put these on your cheat sheet. Okay. So an exponential and a log to the same base are inverses. So for example, 2 to the x. What's the inverse? Log base 2 of x. Now, if you go by strictly our rules of you switch around the x and the y, right? And say, oh, I thought you said if we find the inverse, you just switch around x and y. Yes, that's technically correct. Say x equals 2 to the y. How do you solve for y? The answer is we just invent a function. The function is called the logarithm function. So y equals log base 2 of x is the inverse. If you think about our rule, here's the base. Where's the exponent? Across the equal sign, 2 to the y equals x. Okay. So since this is true, f of f inverse of x is x. And likewise, f inverse of f of x is x. So that means a raised to the log base a of x is equal to x. Exponential followed by a log, or log followed by an exponential. Log base a of a to the x is equal to x. So example, 2 raised to the log base 2 of x. Exponent, log, same base, automatically just pretend this all cancels out. We have x. Or log base 3 of 3 to the 7th power. Okay. Log, exponential, same base, just cancel them out. Answer is 7. Some more examples. 10 raised to the log of 4. Remember that log here means base 10. It's understood that there's a 10 there. So they do have the same base. Exponential, log, cancel them out, 4. Log of 10 to the pi. Understood 10 there, right? So 10, 10, cancel them out. Answer is just pi. E to the ln 2. Cancel these out. 2. Ln of e to the 1.3. These cancel out. 1.3. Or ln, you can think of it as log base e. So log base e of e to the 1.3 is also 1.3. Okay. And a side note, yes, you could check some of these on your calculator. So let me just try to show you. Second function, e to the ln 2. E to the ln2 is 2. And how about what? Ln e to the 1.3. Ln second function e to the 1.3. Ln of e to the 1.3. There it is, 1.3. Okay. Which is the reason why most calculators set up the e to the x and ln x right on top of each other. And likewise log the 10 to the x. They're inverse functions. Just like sine and inverse sine, cosine, inverse cosine, tangent, inverse tangent, right? Okay, and I've already shown you this before. Okay, here's e to the x, goes to 0, 1. Domain is all reals. The range is from 0 to infinity. So for the reflection across the line y equals x, you get the logarithm function. F inverse of x, f negative 1 of x, is ln x. Switch the domain and range. So the domain of this is now the range of this. So this green function goes as high up and down as you want. The range is all reals. The domain was the range here. So the domain is 0 to infinity. So again, you can only take the log of positive quantities. You see from this graph here. Okay, now a review of some properties of logs that you've probably had in intermediate algebra. Okay. Again, for some of this, I realize I might be going fast, but this should all be reviewed. None of this should be new. You should have seen properties of logs before in your intermediate algebra. We're just rehashing them. Okay, so this is sometimes called the log of a product, is the sum of the logs. Log base b of x times y is log base b of x plus log base b of y. That seems kind of unnatural. It's very unnatural. You have to get used to that. And you're welcome to put that on your cheat sheet. So example, log of 4 times 7 is log of 4 plus a log of 7. This is understood to be base 10. Okay. And let me just show that to you just for fun. So log of 28, 1.4, whatever. And I'll also do what? Log 4 plus log 7, exactly the same, right? Log of 28, 1.44, whatever. Log of 4 plus log of 7. It's not times. It's very unnatural. So you kind of have to get used to this. Exactly the same thing. And so log of x times y, log of x plus log of y. And then, well, if you can kind of guess the way this is going to work. Here's a multiplication, addition, right? Multiply, add. So what would seem natural if you divide? Subtract. Log base b of x over y, log base b of x minus log base b of y. The log of a quotient is the difference of the logs. So for instance, ln, I pick log and ln a lot because you have buttons for those, right? We usually don't have buttons for any other bases. So according to this rule, ln of 15 divided by 5 is ln 15 minus ln 5. Okay, let's actually show that. So this is 3, right? So let me hit ln 3, 1.09, whatever. And then I'll hit ln 15 minus ln 5. Excuse me. Here it is, exactly the same. Okay. All right, then we have a power property. So look at this. Log base b of x squared. Well, x squared is x times x. So log base b of x times x. I can use this rule I just talked about back up here. So that's a log base b of the first x plus a log base b of the second, which is also x. So I have 2 of them, 2 log base b of x. Likewise, how about log base b of x cubed? Well, I can write that as log base b of x times x times x. And once again, employ this rule. So it's a log base b of the first one, x, plus a log base b of the second one, which also happens to be x, plus a log base b of the third one. And that means I have 3 log base b of x. Okay. Summarizing, I've got log base b of x squared is 2 log base b of x. Log base b of x cubed is 3 log base b of x. So it looks like I can make a rule in general. Log base b of x to the n is n log base b of x. So it looks like if there's an exponent up here with a log, that n can come down in front. It works the other way too. You can start off with this coefficient and make it climb back up here as x to the n. So we have to be ready to go both ways. So if there's a log, exponent can come down in front as a coefficient, or the coefficient can climb back up as an exponent. That's the power rule. Okay. Put this on your formula sheet. So an example. Log of 2 to the 10th is 10 log 2. Okay, now I know 2 to the 10th is 1024. So 2 to the 10th power, 1024. Okay, so let me try to show you they're the same. So what am I doing? Log of 1024, log 1024, 3.01, whatever. Okay, and then 10 log 2, 10 log 2. Exactly the same thing. 3.01029999, whatever. Okay. All right, so getting back to some more of the problems. 15, e to the 2 ln pi. Now, if that 2 weren't there, if I could cheat, which you're not going to do, but if I could cheat and get rid of the 2 and say e to the ln pi, right? You say, oh, the e and the ln can just cancel out. My answer is pi. I can't really do that now, but I'll hold that thought. Can I move that 2 somewhere? The answer is yes. I'll make that 2 climb back up here as an exponent using the power property. Exponent can climb back up. So e to the 2 ln pi, make this climb up as e to the ln pi squared. And now the e and the ln are next to each other, so I can cancel them out, pi squared. So that's the way that one works. $17, they want me to split up ln of x times x plus 1. Okay. There's a multiplication here. So I do this thing. ln of x plus ln of x plus 1. And in case you're wondering, no, you cannot do anything with that. You might think, oh, can I distribute and go ln x plus ln 1? No, the distributive law doesn't work that way for natural laws. Okay, how about 19? 19 is a combination of this one and this one. So log base 3 of x to the 4th over x plus 1. Okay, so there's a division. So division means subtract. Log base 3 of the top minus log base 3 of the bottom. And then the exponent of 4, this one doesn't have an exponent, so don't worry about it. But this one, 4 can come down, 4 log base 3 of x minus log base 3 of x plus 1. So that's the answer for that one. Okay, so that's the way these problems work. Okay, do a few more, and then that'll be it for today. And so let's see what I got on here. Okay, this one looks more complicated. Log base 3 of all this mess. There's a multiplication, division, division. So log base 3 of 3x plus 2 to 3 halves plus, because there's a multiplication, log base 3 of x minus 1 cubed minus, that's in the denominator, minus log base 3 of x. And this is also divided by that. So minus log base 3 of square root of x plus 1. That's right, it's x plus 1 to the half. And now 3/2 gets to come down. 3 gets to come down. This doesn't have anything to come down. Half comes down. So final answer is 3/2 log base 3 of 3x plus 2 plus 3 log base 3 of x minus 1. Just copy that one. And then minus 1/2 log base 3 of x plus 1. Okay, this one looks real weird. You got a square root inside a square root. But here's the way to think of it. Sometimes I like to say, if you don't like looking at something, then don't look at it. Ultimately, it's ln of this stuff. So it's blah, blah, blah to the 1/2 power. Square root means raise something to the half. Okay, so that's that. Now what's inside? X radical x plus 1. X radical x plus 1. X plus 1 to the half. All of this matches all of this. Okay. Now, I have a property of logs that says I can distribute the half. X to the half. X plus 1 to the half to the half. I can multiply these. So ln x to the half, x plus 1 to the half times a half, 1/4. This is a product, something times something. So it's ln of the first plus ln of the second. And finally, the exponents can come down. So 1/2 natural log of x plus 1/4 natural log x plus 1. The ln stands for natural log. Okay, then 27, they want us to go the other way. Go the other way, write it as just a single log with no coefficients. Okay, so they don't want the 2 there. So what do I want with 2? Make it climb back up. So ln x plus ln x plus 1 squared. Okay, and now there's a plus here. So there's a plus, what do? Multiply. So ln of x times x plus 1 squared. And there we go. Okay. 31. Write it as a single log. Okay, so all coefficients climb back up. This one doesn't have any coefficient. Half climbs up here. 2 climbs up here. ln x minus 1 plus ln x to the half minus ln x squared. Now we know what to do. This plus this minus this. So a single ln, what stays on top and what goes on the bottom? This stays up as a positive. I mean, you can always pretend there's a positive here. Positive stays up. Positive stays up. Negative goes down. So ln x minus 1 times x to the half. But the usual way to write x to the 1/2 is square root of x, right? And then because of the minus, divided by x squared. And that's the way it works. Okay, folks, I'm just about done. I was going to show you one log equation type problem. And I'll do a lot more tomorrow. Okay, solve for x. So a lot of these you have to unscramble to figure out what to do. Okay. So log base 3 of x equals 4. Solve for x. Okay, so just rewrite it without the log. Base is 3. Exponent, cross the equal sign, come back in. So unscramble the log. 3 to the 4th equals x, and 3 to the 4th is 81. 3 times 3 times 3 times 3. Okay. Do a couple more, then I'll stop. Log base 2 of 3x minus 4 equals 3. I don't like the logs. Get rid of the log. Okay. What's the base? 2. Exponent? 3. Come back in for the result. 2 cubed, and you have to watch out. A lot of students would say 2 times 3. It's not 2 times 3, it's 2 to the 3rd power equals 3x minus 4. Okay, 2 cubes, 8. And now it's very easy. Right? Add 4. 12 equals 3x, so x equals 4. Okay, last one, then I'll quit. Log base x of 4 equals 2. Log base x of 4 equals 2. Start with the base, x. Exponent, 2. Come back in for the result. X squared equals 4. Square root property. Ordinarily, you would say plus or minus, but for logarithms and exponentials, we always insist the base is positive. So I don't have to worry about base negative 2, just 2. So x is equal to 2. Okay. All right, folks, I was going to stop there. Tomorrow, I'll do more problems from 5-3, and you'll get your quiz due at 11:59 p.m. tomorrow. Friday's a holiday.
I have a quick question.
Mhm.
I was doing 31 and I ended up at first with your answer, but like the back of the book wanted me to simplify it even more. And so I just continued simplifying. I'm just like wondering, I mean, this might seem like a silly question, but like how, I mean, I'm a little confused on how far you want us to go now. You know what I mean? Like
Well, you should go as far as what I had, I guess, for 31. So raising something to the half means square root, so you should write it as a square root. And so, yeah, for 31, the answer should be exactly like this, if that's what you mean. But did they go farther? Is that what you mean?
yeah, like they instead of changing it to the square root, they left it over as x 1/2 over x2, and then did the exponent division.
Right.
Yeah.
Yeah. You could do that too. I don't think that was the purpose of this problem. So
It doesn't
You could
matter
keep-
though. Okay.
yeah,
That
in this
helps.
case,
Okay.
yeah, I will accept it either way for this one.
Okay, thank you.
Now, if it was easier, like if let's say that was x and that's x squared, you say, oh yeah, definitely cancel an x with an x squared. But let's pretend this was x cubed, right? X cubed divided by x squared. Oh yeah, I know how to do that. This one's a little bit, more of a gray area. So you could do it or not. Okay. All right, any other questions, please? Let me stop the share and check the chat. Okay, anything else? Otherwise, we'll quit. All right, then have a good day, everybody, and we'll see you next time. Okay.
Thank
All right,
you.
bye.